Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 2707, which is extra characters in a string. Let's see the problem statement. You are given a zero indexed in strings S and a dictionary of words dictionary. You have to break S into one or more non-overlapping substrings such that each substring is present in dictionary. There may be some extra characters in S which are not present in any of the substring. Return the minimum number of extra characters left over if you break up S optimally. For example, this is the given S and this is our dictionary. So if you see carefully, lit is already present and code is already present, but S is not present. So that's why it is returning 1 because S is excluded. And the length of the given string will be up to 50. The length of dictionary will be up to 50. Each word in the dictionary will be up to 50. And each word will in the dictionary and S contains only lowercase English letters and dictionary contains distinct words. So the algorithm goes like this. We can take the current character, let's say at given point of time we are currently standing at index any x y z any. So let's say we are standing at 0th position, so we can either take this current position. Take means we will find any character, any strings which is starting from that index of given s, and we will match that if the word is present or not. If it is present, then we will take that word and find the like the minimum number of extra characters for after this word. Okay, and the another option is we will not take this current character, we will start from the next character, then we will call the function recursion function from the next index, and whatever the value it gives we will add 1 into it because we are excluding this current character, so we will add into it. So this is the two options and we will return minimum of these two options. So let's make, and we have to use dp so that we do not calculate the same value again and again, because at some point we will see that at same index we will call that function again and again. So we need to use dp to store each value of each index of the given string. So let's start. Int n will be h dot size, and we will create a dp of size n. So vector int of dp of size n. Initially all the values are -1. Now we will call the recursion function. Let's say return solve, and it will take three parameters, four parameters actually. S, the dictionary value, dict dictionary, and the starting index. The initial starting index will be 0, and the dp obviously. That's it. Now let's make this function. It will return integer solve, and it will take these parameters. Let's make the dictionary as dict, right, optimally, and we will take the address of s because we will not change the s. That's why we can to optimize the space complexity we will use ampersand here. Next we will have the starting index and the dp, which is vector int. We will also use ampersand here so that it reflect the values are reflected in all the functions. Now first we have to check if st is present or not. So we will check if st is greater or equal to s dot size. Then that means we already we already we already visited all the characters in given s. So now there is no characters left. So we can return 0 because at this position we will not find any characters which we are excluding. So we will return 0. Next we will check if dp of st is not equal to -1. That means you already calculated this value. Then we will simply return the value. So dp of st. Now if it is not calculated, then we have to calculate it. and there is two options, one is take and not take of the current character. So let's calculate the no take option first. So int no take is equal to solve, it will take s the dictionary, and the starting index will be the next index of the current index, which is st plus 1, and the dp, and we have to add 1 because we are excluding the current character. So in no take case we have to add 1 here. Now in take case, when we are taking the current character, so initially let's say take is int max, and as we are taking this current value, that means we have to find the words which is starting from this index of s, and it also contains all the whole characters of that dictionary. Okay, then we will proceed further. So let's check for auto item dictionary. For all the characters, we have to check if it is present, this character, current string is present in s or not, starting from this given index. Okay, so let's make bool flag. Initially let's keep it true. Next, the starting index is the st. This is the starting index of s, not this it means current string. It is starting index of the given s. Okay, now for int j equal to 0, j less than it dot size j plus plus. It is the checking part. You can also cut the substring if the length is if the given the current string length is less than the st plus this size. If it is present in s, you can cut the substring of s. Then you can directly check if it is equal to this current string or not. But it will take some extra spaces. That's why I am checking it with a loop. Okay. So in j equal to 0, j less than it dot size, j plus plus, we will check if, first we need to check if int like the our main strings index is present or not. So is dot size, if it is like greater equal to st dot size, that means there is no other characters. So we make flag is false and break. Next, we need to check if the current character of this string and our given string is equal to or not equal to. If it is not equal to, then we can directly make it false and uh, make the flag false and break it. So just check s of int is not equal to it of j. If it is not equal, then make the flag false and break. And if it is equal, then just increase the ind, because j is already increasing here, so make ind here. Now we need to check if flag is present, means we find the current string in our given string. Okay, then we need to update the text is minimum of the text and the answer of after taking this current string. So after taking this current string, that means we need to call our helper function solve is dictionary. The starting index will be current starting index plus the size of the current string, which is it dot size, and the dp will be the same dp. That's it. And after this for loop, we need to return dp of, we are directly storing it and also returning it at the same line. So dp of st equal to minimum of take no take. Okay, that's it. Let's see will it work or not. It is giving wrong answer, which is because this is vector, not vector. Okay, update that. Now it is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. So the space complexity will be, here we are using a vector of dp of size n, where n is the size of s. So it is taking big of n size, and we are not using any extra spaces, any other recursion function. So the overall space complexity will be big of n, and the time complexity will be for each of the indexes of given s. We are calling this recursion function, and this recursion function is taking for each of the call, it is taking a length of, let's say, d, where d is the length of dictionary, and because we have to traverse all the words present in dictionary, and for each of the words, if the average size of the words is m, then it is also taking big of m, this inner loop. So this overall nested for loops is taking big of d cross m, where d is the length of dictionary and m is the average length of each word, and we are calling this for each position or each index of the given s. So the overall time complexity will be big of n cross d cross m, where n is the length of given s, given string, where d is the length of given dictionary, and m is the length of average word present, or average string present in dictionary. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.